All right, 8th graders, lesson 77, inequalities with negative coefficients. And there in the introduction it talks about solving inequalities. If you remember, inequalities are A is greater than B, or less than, or equal to, or not equal to. But anyways, when solving an inequality, what we're going to be seeing today is that when we multiply or divide, we swap this around. So if we said A was greater than B, but then we did a multiplication division, it's going to end up A is then would be less than B. So let's kind of show how that works here. All right, here you see the same chart. So let's just say A is 6 and B is 2. And then let's say C, so this is A, this is B, and let's say C is 3. So in this first one here, if we add A and C, we'll get 9 is greater than 5, so that's true. Or 6 minus 3 is going to be greater than 2 minus 3 is a negative 1. So this one is true. Now, in the next one, though, we start dealing with multiplication and division. If C is positive, so it's a positive 3, then 6 times 3 will be 18, and 2 times 3 will be 6. So that's true. Again, that side is bigger. And 18, or 6 divided by 3 will be 2, 2 divided by 3. So 6 divided by 3 would be 2, and 2 divided by 3 would be 0.666. So again, that one is true. However, if C would be negative, then the symbol switches, because 6 times 3 would be a negative 18, and 2 times a negative 3 would only be a negative 6. So by changing it to a negative number, in this section down here, we change that symbol. Again, in this one right here, if we say 6 divided by negative 3, that'll be a negative 2, is going to be less than, again, negative 2/3 would be negative 0.666. So now this number is larger. So by changing the number that we're working with to a negative, these symbols got changed around. Before, over here, they were larger. Down here, they're smaller. So let's do some of these examples then. Example 1, multiply both sides of the inequality by a negative 1 and explain how to preserve the truth of the inequalities. That last phrase there, you might be a little confused by, we'll go over that. So I have 6 is greater than 5. Multiply both sides by a negative 1. So 6 times a negative 1 will be negative 6. 5 times a negative 1 will be a negative 5. And now 6 is less than a negative 5. And then it says, and explain how to preserve the truth of the inequality. And to preserve the truth of the inequality, we needed to switch the sign. So we would say we switch the sign to keep the inequality true. That's what we needed to do. So negative 6 is less than negative 5. So our numbers kind of stayed in the same spot. We multiplied them both by a negative 1. But when we did that, we had to change our symbol around. So it's really all you're doing here is re-evaluating. You're doing some math on each side of the equation. And then after you get done, you're re-evaluating this. But the truth of it is, the rule here that we kind of see is that with a negative number that we multiply by both sides, it will always switch the symbol around. All right, let's look at example 2. We got negative 3x minus 10, and that is greater than 8. Now again, we need to solve for x here. So first thing I'm going to do is add 10 to each side. So I'll have a negative 3x is greater than, add a 10 over here, 18. So I didn't add, or I added or subtracted, I didn't multiply or divide in this first step. So the inequality, the symbol stays the same. However, in the next part we're going to change this because we're going to do some division. I'd have to divide by a negative 3. So the x will be all by itself. So I'm going to have to change the inequality now because I did a division problem. X is going to be less than negative 6. Okay. And then they ask us to graph that, so we draw the number line. Negative 7, negative 6, and a negative 5. And it does not include the negative 6. So I'm going to go with an open circle there, and then I'm going to draw my line going that direction. So x has got to be less than a negative 6. And if you want to, pick a number that's less than negative 6. Negative 8. So we put that in. Back up here, negative 8 times a negative 3 will be 24. Minus 10 is got to be greater than 8, and 24 minus 10 is 14, is greater than 8. So that stayed true. However, if we were to pick a number over here on this side, like a negative 4, it would not be true. So let's try that. I'll do a different color here. Negative 4 times negative 3 would be a 12. Minus 10 is greater than 8. 12 minus 10 is 2. So we see that this is not true. So that's why we say any numbers have to be on this side for this original formula to be true, or inequality to be true. Alright, let's go on to example 3 here. We have solve and graph. I've got a negative 5 and then x minus 3 is greater than 5, and then x minus 3 again. Okay, so first step would be to distribute. Let's distribute here. Negative 5x plus 15, because a negative times a negative is a positive. And then I've got a 5x, and 5 times a negative 3 will be a negative 15. And now I can start working with the inequalities here. The first thing that I want to do is, let's see if I can subtract 5x from this side. And why don't I minus 15 from over here. So let's see, now I'll have negative 10x is greater than a negative 30. These canceled out over here. Alright, and then the next step here is to divide by a negative 10. So that'll cancel out. So I'm going to have x, and then because I did division, I have to swap that symbol around. Negative 10 divided by is going to be negative 30 divided by negative 10 is going to be a positive 3. And then again, to graph that, a 2 and a 3 and a 4, and then we would say x is less than 3, so I put an empty circle there and color that way. So again, you could pick any number less than 3 and put it back in this formula up here, and this will be true. If you pick a number greater than 3 and put it in here, this formula will not be true. Then this side will not be larger than this side. All right, example 4 here. Marcy sees a shirt that costs $50. She will not buy it unless it is $30 or less. To find the percent decrease in the price required, she solves the inequality. So she wants the price of the discounted to be less than $30. So she wants the amount that she's going to pay to be over here, less than 30. And the original price is $50. So how much of a decrease here times x, 50 minus what percentage of 50 will be less than 30? Because you've got to pay less than 30. She won't pay anything more. It's going to be $30 or less. So we can do the math here. The first thing that we're going to do is go ahead and subtract the 50 from each side, because it's possible. Minus 50 over here, cancel that out. Minus 50 over here. So if we write that, we'll have a negative 50x is less than or equal to negative $20. Alright, next step then is to divide by a negative 50 on each side to cancel out over here. So x, and now because I did division, I got to switch the symbol around, will be greater than or equal to 20 over 50. Alright, now let's reduce this. That's 2/5, and I know 2/5 is equal to 40%, or you could increase this to negative 40 over a negative 100. Those cancel out, so you'd have a 40%. X is greater than or equal to 40%. So she needs at least a 40% discount on the shirt before she will buy it. So if she goes in and she's got the 30% off coupon and its regular price, she's not getting it. If it's sale priced at 15% off and she has a 30% coupon, that's 45%. That will be a large enough percent for her to be able to purchase it for $30 or less. So she needs a percent off greater than or equal to 40%, and then she will buy the shirt. All right, that's it. You can get started on your practice set, 8th graders.